Okay, we're going to jump to the next one. And the next one is the next piece we talked about. So let's start. So this one's all about evaluating a claim. So the thing I want you to always realize when we evaluate a claim is what we're going to do first is we are always going to assume the claim is true. Okay, so we're going to assume that claim is true. So whatever someone claims, we're going to grant them it or say, hey, we believe you. Whatever you're saying is true. What we are going to do is we're going to gather a sampling distribution. And what we're going to do is we're going to use that sampling distribution to find the percent chance of getting that result. So what we want to do is we want to say, okay, you believe that 70% of Americans support a certain idea. Like, okay, we're going to grant it for you. We're going to say 70% of Americans. And what we're going to do is we're going to go out and we're going to gather a sample using all the methods we've learned. We want them unbiased. We want to get a large enough sample size that we kind of reduce our variability. But what we do is we collect that sample size over and over again. So we go and talk to 30 people and then 30 people and then 30 people and then 30 people. We do it so many times. We build this little, like kind of almost, it looks like this. And we go and we look and see where does the 70% fall. So if the 70% had fallen, in this case, it's got 10, but let's say 70% had fallen way out here. Let's say that this was 70%. That would be evidence to question the claim. Basically, we're saying, hey, you're claiming it's 70%. But when I went and talked to all these people, I was down here in the 40s and 50s. So I'm not necessarily believing you're 70%. However, let's say their claim was 70% and we gathered it 70% was like right here. What that would say is it kind of falls in the pattern of the data. So, their claim isn't necessarily wrong. So let's take a look at the question. Pennies made prior to 1982 were 95% copper. Because of copper content, these pennies are worth about 2 cents each. Pennies made after 1982 are only 2.5% copper. Jenna read online that 13.2% of pennies in circulation are pre-1982 copper pennies. Jenna has a large container of pennies at home. She selects a random sample of 50 pennies from the container and finds that 11 are pre-1982. Does this provide convincing evidence that the proportion of pennies in her container that are pre-1982 are greater than 0.132 or 13.2%? So in this case, what's the population? Well, the population is everybody who can be sampled. So it's not all pennies. It's all pennies in this container. So it's all pennies in the container. So be careful, because in this case, it's not all pennies in existence. It's only where we could put the sample. And it says, what is the parameter? Well, the parameter that we're looking for is somebody's claim is that the true proportion, the P is 0.132. What is the sample? What did she do to get the sample? She did a sample of size 50 pennies. And the statistic here was that proportion she got. That proportion she got, that P hat she got, was 11 out of 50, which is 22%. So again, I would kind of go with the decimal in this one, stay away from the fractions. The fractions aren't wrong, but I'll tell you it's going to be easier to work with as decimals. Does Jenna have some evidence that more than 13% of her pennies are pre-1982 copper? In this case, I'd say yes, she does. 22% is greater than 13.2%. So there is some evidence. In this case, it's evidence for it. It's not proof of it. And again, we're never really going to have proof, but the thing we really want to look at is we want to see, is that number far enough away from that claim of 0.132 that we actually have some information here, some like valid information, or did she just get lucky with the 50 pennies and happen to grab a lot of pre-1982 ones? So in this case, the two things that could have happened is that the percent in the container is actually 13.2%. And she got lucky with her sample. The other option in this case is that the percent in the container is greater than 13.2%. So what's going to happen is the following. We're going to go ahead and we're going to do a simulation of 100 of size 50 from the copper penny. So basically what we did is, let me zoom in on this. what ended up happening was they did it 100 times. They did it 100 times, and of the 100 times, this is what they ended up getting. Okay, so this is what they ended up getting when we did 100 times. There's the one dot on the graph at 22%. So that is this person right. That is Jenna. That's Jenna right there. And what is that? When we look at it, it's 1 p hat of 0.22. It's a sample proportion. Assuming that 13.2% of the pennies are pre-92, is it surprising to randomly select 50 pennies for which 22% or greater? So again, how many of them are 22% or greater? We got 1, 2, 3, 4. In that case, we end up with 4 out of 100, or 0.04, are greater than, or 22% are greater, or 22% or greater. Remember, our magic number is 5%. This is a significant result. This is a significant result. So what does it say in this? Based on our evidence, is there convincing evidence that more than 13.2% of Jenna's pennies are pre-1982? And the answer is yes. Because assuming Jenna's container actually has 13.2% pre-1982 pennies, the chances, or the probability of getting 22%, which again is that 11 out of 50 Jenna got, is 0.04. Of getting that 22% or greater, forgot that part, or greater, is 0.04. And that, again, that is a significant result. So this says to me that Jenna's container probably contains more than 13.2% pre-1982 pennies. So this is what we're going to be working with. Again, we're working with vocabulary and kind of playing with the numbers. We're going to learn a couple formulas, but realistically, what we really need to feel good about when we come out of this is the vocab. If you can come out of the vocab with this, that is a really important part, because the month of February and March are basically going to be spent doing inference for proportions and inference for means. So again, please try these sheets. These check your understandings. Ask me questions in the reflection. Ask me questions in class. Please, let's get this vocab down. This is 40% of the test, and I want to make sure everybody's got a good handle on it. So I will talk to you later.